Hi friends, welcome to my channel Mathematics Idea. This video is also available in Hindi. यह वीडियो हिंदी में भी उपलब्ध है. If you are happy with the content in this video, please press like, share and subscribe to be updated with the channel. Press the bell icon to get the notifications. If you are the first time viewer of this channel, I will request you to go through my introduction video first. This will help you to understand the presentation structure of the course content. Today we are at the detailed explanation class 1 for principle of mathematical induction. Before this detailed explanation class 1, we had completed the basics class of the mathematical induction. So I will request you to first go through the basic class of mathematical induction. This will help you to understand the each and every step followed in this detailed explanation class. Okay? Now, let's put the intent of this class. In this class, we will discuss the different variety of the problems in principle of mathematical induction. Okay, what we will do? We will discuss the different variety of problems in principle of mathematical induction. Once we discuss the different varieties of problem, we will target one problem for each category. We will target one problem for each category and we will see in a detail how we can solve the each problem of that category. Okay. Once we had solved one problem in various categories, after that we will have a workshop session. In those workshop sessions, we will be having a number of problems in which we won't go in that much detail, but we will solve the problem very fast as you are able to approach the problem after this detailed explanation class. Okay, is it clear? So this detailed explanation of this class will help you to navigate through the workshop sessions and pick up the problems as fast as possible. Okay. Now let's get started. I had categorized the problem based on the usage of n. In my basics class, I told that whenever a certain problem which is having a term of n where n belongs to natural numbers like that, then those problems are known as generalization problems. Okay, so n is a main point in which all the different categorizations will hinge. Okay, all the different problems categories will hinge. This is the pivot point of the n and all are what you can say hinging about this point. Okay, so based on the usage of n, I had come up with 11 type of the categories. Okay, so first type of problem, n is at base. Okay, so for any number, if it is represented in the form of 2 to the power of 3, suppose, then 2 is the base and 3 is the exponent. Okay, it's clear. So when n is at the base, n is at the base and there is a constant power, like we discussed in the basic class one problem, that sum of the first n natural numbers. The sum of the first n natural numbers, what is the power of n? N is 1. So 1 to the power of 1, 2 to the power of 1, 3 to the power of 1, 4 to the power of 1. So like that, entire n is having power 1. Okay, done. So such type of problem is constant power because power is not varying. It is 1. 1 to the power of 1, 2 to the power of 1, 3 to the power of 1, like that. It may be square of the first n natural numbers. 1 square, 2 square, 3 square, 4 square. So we are seeing the power is 2 for entire set of the sum. Okay, so that type of problem is constant power problem. Now again, n is at base. N is at base, but it is having variable power. Variable power like 3n cube plus 5n square plus 7n. So we are seeing that for each and every term, the power is varying, right? Like 3n cube, power is 3, plus 2n square, power is 2, plus 7n, power of n is 1. So each and every term is having variable power. So that is another type of problem we are going to discuss. N involved in series or sequence. Some series or sequence n is involved, like 1 plus 3 plus 5 plus 7. So what is the common in this? That the difference is 2. Such type of series and sequences. It may be 1 into 2 plus 2 into 3 plus 3 into 4. And you have to prove that it will be equal to something. So LHS will be equal to RHS. You have to prove that we will see in the detail what we have to do. But I am telling how our LHS will look like. So when n is involved in a series and sequence, it will look like 1 plus 3 plus 5 plus 7, or 1 into 2 plus 2 into 3. So certain sequence or series is involved in this. This is the another type. Now, statements of divisibility. Some statements like n cube minus 1, n cube plus n square plus 4 is divisible by 3, is divisible by 4, is divisible by 5. We have to prove such type of statements, that certain number which is represented in the form of n is divisible by a number like 5, 6, 7, 8 or any number. Okay, such type of problems are statement of divisibility. Now a to the power n type of problem. A to the power of n type like 3 into 2 to the power of n plus 5 to the power of n, where a is constant. See here, where a is constant. So 3 into 2 to the power of n plus 5 to the power of n. Here 3 and 5 both are constants, right? So constant to the power of n type of problem. So this is another variety or another category of problem. N number of digits. Suppose some sum is there. 9 plus 99 plus 999 plus 9999 plus like that. So when the number of digits increases and we have to prove for something, we have to prove for some statement in that one. So such type of problems. So n number of digits. There are n number of digits in that one. So it digits first n for 9 there is one digit, 99 2 digits, 999 3 digits, like that 1 2 3 4 like that it will go to till n digits. So this is n number of digits type of problem. N in factorials. What is factorial? We will discuss it in permutation and combinations, but I will tell you in a brief what is factorial once we go through this category of problem, category number 7. Now category number 8. N is in trigonometric function. So trigonometric function is like sine, cos, tan. In that n is involved. Okay, so such type of generalization problems are there in category 8. Category 9. N in inequalities. Whenever there is a sign of inequality, that LHS is lesser than 2. Such type of problems. Okay, so n is in inequalities. This is another category. Another category is variables involved. What is the difference between category number 10 and category number 5? We can see that in category number 5 we are using a to the power of n, where a is a constant. Here we are using x to the power of n. X is not a constant here, it's a variable. So like x to the power of n minus y to the power of n is divisible by x minus y. Such type of problems where we are involving with variables. So variables involved. Okay, such type of problem. Next, at last we will discuss the second principle. So second principle of mathematical induction, we will discuss the recursion problem, and we will close out the categories discussion. Okay, so this is all about 11 categories which I had done for an easy structured approach. This is an easy structured approach to learn how to solve each category of the problem. Okay, now in this class, definitely these all 11 problems can't be solved in single class. Okay, so in this class we are targeting on these first 4. So difficulty level will increase, and this is the difficulty level from 1 to 11. So we will solve first 4 in this detailed explanation class 1. Rest 7 will be carried out in other detailed explanation classes. Okay, so now we are in category 1, category 2, category 3 and category 4 class in this mathematical induction. Okay, now let me rub it out. So I will repeat what are our 4 categories. 4 categories is, first is with n is with constant power, n is with variable power, n is with sequence and series, n is with divisibility. So power problem, divisibility problem and series and sequence problem. So these are the major categories which we will discuss. Okay, now let us discuss first the constant power problem. Constant power problem, I will use a problem or a statement as sum of the square of first n natural numbers is n plus 1, 2n plus 1 by 6. Okay, so how my mathematical statement is represented? It is represented by P of n. Now this P of n is sum of square of first n natural numbers. So I told natural numbers start from 1. Okay, natural number starts from 1. So 1 to n, how to write the sum of the squares? It will be 1 square, 2 square, 3 square up to n square. These all summed up. So I will write it as sum of it is 1 square plus 2 square plus 3 square plus dash dash up to n square. What will be this? This will be my LHS. Okay, if you are having any doubt, please go through my basic class to understand what we are doing with LHS and RHS. This will be equal to, I have to show that it will be n plus 1 to n plus 1 by 6. Okay, n plus 1 to n plus 1 by 6. So this is what we have to prove. Okay, now my principle of mathematical induction is a 3-step procedure. In this 3-step procedure, first procedure is to check. What is that to check? Check for initial value. Okay, check for the initial value. So for this domain I hadn't written, it is for all n belongs to natural numbers. Okay, for all n belongs to natural numbers. Okay, so as all n belongs to natural numbers, my initial value will be 1. It will be 1. Okay, so my first step is to check whether P1 is true or not. For my P1, what will be my LHS? So for my P1, my LHS will be 1 square, because for Pn there are n terms, that's why it is 1 plus 2 plus 3 plus up to n square. Once it will become P1, then it will be 1 square. Okay, so it will be 1 square, which is equal to 1. Okay, done with it? Okay, now see how my RHS is. RHS is n plus 1 2n plus 1 by 6. For what? For Pn. For Pn. So I have to substitute n equal to 1 for my P1, because Pn is equal to n plus 1 2n plus 1 by 6. So what my P1 will be? 1 plus 1 2 into 1 plus 1 by 6. So let's do that. It will be 1 into 1 plus 1 into 2 into 1 plus 1 by 6. Okay, so it will be equal to 1 into 2 into 3 by 6, which is equal to 1. Okay, so my LHS equal to 1, RHS equal to 1. So LHS equal to RHS. This shows that P1 is true. Done with it? Okay, this shows that P1 is true. Okay. Okay. Now, what is my next step? My next step, once P1 is true, I have to assume that Pm is also true. So now my Pm is also true. What is the output of this step? With Pm is true, the output is we have to come up with the concrete statement. So second step is Pm is true. If my Pm is true, then I have to replace my n with m. Then it will become LHS, let's write LHS and RHS both in same statement. Then it will be 1 square plus 2 square plus 3 square up to m square is equal to m plus 1 2m plus 1 by 6. In both LHS and RHS we had substituted n equal to m. Okay, so 1 square plus 2 square plus 3 square plus m square will be m plus 1 by m plus 1 2m plus 1 by 6. This is the concrete statement which we had arrived by assuming that Pm is true. Third step, which is our main induction step. In this step, we have to show that Pm plus 1 is also true. Now, how my Pm plus 1 is? Pm plus 1. So, my Pm plus 1, I will go with my LHS. So, how my LHS will be? My LHS will be 1 square plus 2 square plus 3 square plus dash dash up to m of m square. At last we will add m plus 1 square, because for m we had written up to m. For m plus 1 we will write up to m plus 1 terms. Clear? So this will be my LHS, right? Now, before moving to further step, what we have to do? We have to first anticipate that how my RHS will look like, and we have to work towards that. Okay, so what should be my output of this Pm plus 1? So I will rub this out because P1 initial check is done. So this is now no more required. So this is just an initial check, so I don't need it. So to see that how my RHS will look like, I will substitute n is equal to m plus 1. Okay, n is equal to m plus 1 in RHS. So once you substitute, you will get m plus 1, n is equal to m plus 1, so it will be m plus 1. Now my n plus 1 will become m plus 2, and 2n plus 1 will become 2m plus 3 whole divided by 6. Okay, so let's keep this as our target. Okay, let's keep this as our target, and we have to achieve this by using this concrete statement in this induction step. Okay, this is what we are going to do. Now, from this 1 square till m square, from this 1 square till m square, we had got a concrete statement that it is m plus 1 to m plus 1 by 6. Let's put it here. This is equal to m plus 1 to m plus 1 by 6. Okay, so till m square we can substitute this. Done? Now we are now left with m plus 1 square. Put it here, m plus 1 whole square. Done? Okay, any doubt? Right. Now in these two terms, m plus 1 is common. Let's take m plus 1 common. So it will be m plus 1 common. So you will be left with m 2m plus 1 by 6. Okay, if you will take m plus 1 common, you will be left with m 2m plus 1 by 6 over here. Okay, and for this you will be having m plus 1 whole square. Sorry, as m plus 1 you have took out, there will be only m plus 1 left over here. Okay, this m plus 1 into m plus 1, it will give m plus 1 whole square. This m plus 1 multiplied with m into 2m plus 1, it will give m plus 1 to m plus 1 by 6. Okay, so m plus 1 is taken common. Now you take LCM and multiply m with 2m plus 1. So once you multiply m with 2m plus 1, it will be m into 2m, so it will be 2m square, plus 1 into m, it will be m, so it will be 2m square plus m. Okay, let's write that. So I will use my left hand side of the board. So it will be 2m square plus m by 6. Okay, plus m plus 1. Now you take LCM, you will get 2m square plus m plus 6m plus 6 whole divided by 6. Okay, so once you add the middle terms, you will get 6m plus m is 7m plus 6 by 6. Now factorize it. So for factorization, you take 2 and this 6. So 2 multiplied by 6 is 12. Now this 7 can be distributed as 3 plus 4 and 3 into 4 is 12. 6 into 2 is 12. Okay. So like that we will complete the factorization for this. 2m square plus 3m plus 4m plus 6 whole divided by 6. Okay. So we had missed one term which is m plus 1. I will write it out here. So m plus 1 is outside. So it will be m plus 1. This is multiplied with m plus 1. This is entirely multiplied with m plus 1. This one is entirely multiplied with m plus 1. Okay. So now you take m common from here. So it will be m plus 1. If you take m common, it will become 2m plus 3. And if you take 2 common from here, it will become 2m plus 3 whole divided by 6. Okay. So once you take this 2m plus 3 common from these two, then you will get m plus 2, 2m plus 3. Okay. So this is also not required, PM statement. Let me rub it out. Okay. So once you take 2m plus 3 common, you will get m plus 2. Then you will be having 3 terms. Those 3 terms are m plus 1, m plus 2, 2m plus 3 by entire 6. Okay. Is m plus 1, m plus 2, 2m plus 3 by 6. So it will become m plus 1, m plus 2, 2m plus 3 whole divided by 6. Done. So is this what I was looking after? Yes. This is what we had anticipated, that it should be m plus 1, m plus 2, 2m plus 3 by 6, and we had arrived to that. Okay. So my Pm plus 1 is true. I had taken LHS and I got what my RHS is. This is my RHS. So P m plus 1 is true. My Pm plus 1 is true. That's why my Pn is true. This is my conclusion. Okay. This is my conclusion that Pn is true. So this ends the first category of problem of base n with a constant power. Now we will go with the second sum, which is with variable power. Okay. My problem is n to the power of 5 by 5 plus n cube by 3 plus 7n by 15 is a natural number. Is natural number for all n belongs to n. Okay. So now first we have to do the check. Let's get carried with our PMI 3-step procedure. So first is I have to check for P1. So for my P1 I have to substitute n equal to 1. So it will be 1 to the power of 5 by 5 plus 1 to the power of 3 by 3 plus 7 into 1 by 15. Okay. So this will be my LHS. Okay. So this LHS will be 1 by 5 plus 1 by 3 plus 7 by 15. So take LCM, it will be 15. So you will get it over here 3 plus 5 plus 7. So it will be 15 by 15. This is equal to 1. So this one is my natural number, right? So P1 is true. What I got? I got that P1 is true. Now I will go for my PM now. Second step, I will assume that my PM is true. Once I assume that PM is true, I will come with a concrete statement. So Pn, we are having n to the power of 5 by 5 plus n cube by 3 plus 7n by 15. So Pm, we have to substitute n with m. So we will get m to the power of 5 by 5 plus m to the power of 3 by 3 plus 7m by 15. So this is my LHS. Now we had told that this is a natural number. So it will be any natural number. Let us indicate that natural number by k. Okay, let us indicate that natural number by k. Any doubt? Okay, so this is my concrete statement, okay, which I had arrived by assuming that PM is true. Now my third step is the induction step. In this step I have to show that PM plus 1 is true. So this is what I have to show. This is what our aim is. So how my PM plus 1 is look like? So LHS will be of PM plus 1 will be m plus 1 to the power of 5 by 5 plus m plus 1 to the power of 3 by 3 plus 7 m plus 1 by 15. Okay, so this is how my LHS will look like. Now the time had come where we have to use Pascal's triangle. Now let me take you through what the Pascal triangle is and how it will look like. So this is the second category problem in this category of problem, we are told that there will be a base of n and with a variable power. So we had seen that here the power is variable, that is 5, 3 and 1. So this is the n base with a variable power type of problem. Now we had struck with the expansion of m plus 1 to the power of 5. How to do with the Pascal triangle? Pascal triangle is a very simple triangle. You just has to write first 1. Okay. After that you write again 1 and 1. This is the basic step you have to do. Third step, you have to start with 1. Sum these two. 1 plus 1, it will be 2. And with 1. Next, start with 1. Now, 1 plus 2, 3. 2 plus 1, 3. And with 1. Are you getting? I have to start with 1 and with 1. In between, whatever I will encounter, it will be the sum of above two terms. Okay? Start with 1. Sum of 1 and 3, 4. Sum of 3 and 3, 6. Sum of 3 and 1, 4. 1 and with 1. Now start with 1. 1 plus 4, 5. 6 plus 4, 10. 6 plus 4, 10. 4 plus 1, 5. And with 1. Like that you can continue to n number of steps. Okay. So this is how a Pascal triangle had come up with. What is the significance of this triangle now? In the expansion such as m plus 1 to the power of 5 or m plus 1 to the power of 3, how easily I can expand it? Okay. So for, you can see first row, this is dedicated to 0, power of 0. So m plus 1 to the power of 0 will be 1. So this is the 1. Second is dedicated to power 1. Like 1 plus m to the power of 5 will be, so first what you have to do, as it is 1 plus m to the power of 1, you have to first put m to the power of 0 multiply here, m to the power of 1 you have to multiply here. So you will get the expansion. So 1 into m to the power of 0 is 1 and 1 into m to the power of 1 is m. So it will be 1 plus m. So this is the 1 plus m to the power of 1 expansion. Now for the power of 2, that is 1 plus m to the power of 2, you have to start with 0. So m to the power of 0, m to the power of 1, here it will be m square. So how my expansion of 1 plus m square will look like? It is 1, 2 to the 2m plus m square. So 1 plus 2m plus m square. This is how my 1 plus m whole square will look like. Now this will be for 3, this will be for power 4 and this will be for power 5. So we will be needing this 3 and 5 because here we are having m plus 1 to the power of 5 and m plus 1 to the power of 3. Now let's expand it. So m plus 1 to the power of 5. So this will be my row. This will be my row of interest. So it will start from m to the power of 0, m square, m cube, m to the power of 4 and m to the power of 5. Okay. So it will be 1, 5m, 10m square, 10m cube and 5m to the power of 4. After that m to the power of 5. So it will be 1 plus 5m plus 10m square plus 10m cube plus 5m to the power of 4 plus m to the power of 5. Okay, so this will be the expansion of m plus 1 to the power of 5. Okay, this is the expansion, whole divided by 5. Now m plus 1 to the power of 3 by 3. 3 is my this row, third row. In this I have to start from 0, m to the power of 0, m to the power of 1, m square, m cube. Okay, so it will, how it will look like: m plus 1 to the power of 3, 1 plus 3m plus 3m square plus m cube. Let's write it. So it will be 1 plus 3m plus 3m square plus m cube by 3. Okay, now first term got sorted out. Okay, second term got sorted out. Okay, now let's come to our third term. Third term is 7m plus 1 by 15. Okay, till this clear? Okay. Okay, now in this pm plus 1, how my RHS should look like? It should be any integer. Okay, any integer greater than 0. Okay, that is the natural number. So I should come up with any integer number for this pm plus 1 statement. That is how my RHS will look like. It may be, I will suppose some number p, or p, it will be confusing because we are using it for our mathematical statement. So I will consider it as r. Okay, I should come up with any integer r in my RHS. That is my main aim. Now how I will come by that number r? So you can see here, m to the power of 5 by 5, m to the power of 3 by 3, 7m by 15 is equal to k. So now extract this LHS in our pm plus 1. How we will extract? So this is the one. Sorry, this is the one. M to the power 5 by 5. This is the one. M to the power of 3 by 3. So with m to the power of 5 by 5, this one. M to the power of 3 by 3, this one. And this 7m by 15, this one. So this all three is equal to how much? It is equal to k, because sum of m to the power of 5 by 5, m to the power of 3 by 3 and 7m by 15 is k. I will rub the Pascal triangle because as we had done the expansion, there is no use of it. Okay, there is no use of it, so I am rubbing it. Okay, now what we will do? We will take m to the power of 5 by 5 plus m to the power of 3 by 3 plus 7m by 15 in one bracket. Okay, now what we are left with? We are left with 1 plus 5m plus 10m square plus 10m cube plus 5m to the power of 4 in first. In second, we are left with 1 plus 3m plus 3m square by 3, and in last term we had left with 7 by 15. Okay, now let's do this. Plus, what I will do, I will take all the constants out. In this, constant is 1 by 5, in this constant is 1 by 3 and in this constant is 7 by 15. So let's do that. Take all the constants out. 1 by 5 plus 1 by 3 plus 7 by 15. Okay, I had taken the constants out. Now, why I had taken the constants out? Because I can see from this term 5, 10, 10, 5, it can be divisible by 5. Because I can take 5 common, then it will be 5, then it will be m plus 2m square plus 2m cube plus m to the power of 4. And that 5 will get cancelled. So this entire m term, whichever is left, is an integer because m belongs to natural numbers, right? So m is an integer. That's why I will get this as integer. Here also, if I will take 3 common, then it will be m plus m square and 3 will be cancelled out. So it will be m plus m square, and this is also an integer. So this is what the logic behind why I separated all the constants out. So once I separate all the constants out, I will get that entire this m to the power 5, m to the power of till m to the power of 4 is an integer because it is 5 is get cancelled out. Here 3 got cancelled out. Okay, so all the m terms are now integers. So I can write it as plus 5 you take common, then it will be m plus 2m square plus 2m cube plus m to the power of 4 by 5, right? So we had accounted for 1 by 5, which is here, m to the power of 5 by 5, which is here, and rest all terms we had written here. So this is completed. Now let's come to this one. In this, it is 1 plus 3m square plus m cube by 3. In this one, m cube by 3 we had already accounted, m cube by 3 here, and after that we are having 1 by 3. This 1 by 3 is done over here. So we are now left with 3m plus m square, 3m plus m square by 3. Okay. So, and at last we are left with 7 by 15, which we had already accounted. So third term is also already done. So this term is done and this term is done. Are you getting? Okay. So now in this expression, everything we had covered from this. Okay. Now let's simplify. This is equal to k from our concrete statement. This we need to solve. This 5 got cancelled. So this entire thing will be some integer I. I will take it as I. Here 3 got cancelled. This will be an integer. I will take it as L. So it will become a simple step as k plus 1 by 5 plus 1 by 3 plus 7 by 15 plus I plus L. Okay. So this is an integer, this is an integer, this is an integer. We have to prove that this is integer. So let's do that. K plus, what will be the LCM? 15. 3 plus 5 plus 7 plus I plus L. This is 7 plus 3 10 plus 5 15. 15 by 15 is 1. So it is k plus 1 plus I plus L. This entire term is an integer which is a natural number. Okay, because this integer is greater than 1, because k is greater than 1, so added with anything it is greater than 1 always. So this is an natural number. Okay, so my Pm plus 1 is true. From this what I am getting, my Pm plus 1 is true. That's why my conclusion will be Pn is true. Okay, my Pn is true. This is my conclusion. Okay, this solves the second category of the problem. Now let's move toward the third category of the problem. In third category of the problem, we are having a sequence or series type of problem. Okay, we are having a sequence and series type of problem. This is my problem. Problem is 1 into 3 plus 2 into 4 plus dash dash up to n into n plus 2. So we can see if n is 1, another term is 3. So there is a difference of 2. So it is written as n into n plus 2, where n starts from 1. Okay. Now let's solve this problem. First, a structured 3-step approach. We will do first check step. So P1. For my P1, how my LHS will look like? My LHS will be 1 into 3, which is nothing but 3. What will be my RHS? RHS will be 1 by 6. I have to substitute 1 in place of n. So it will be 1 plus 1, 2 into 1 plus 7. So this will be equal to 1 by 6, 1, 2, 9. 18 by 6, which is equal to 3. So I can see here LHS is equal to my RHS. So my P1 is true. Okay, my P1 is true. Now let's come to our assumption step. In our assumption step, we had assumed that Pm will be true and we will come up with a concrete statement. So what is my concrete statement now? I will write it as Pm. So my concrete statement will be 1 into 3 plus 2 into 4 plus dash dash up to m plus 2 is equal to 1 by 6 m plus 1 2m plus 7. Okay, so this is the concrete statement which I had arrived by assuming that Pm is true. Okay, now come to the induction step, which is our P m plus 1. So in this Pm plus 1, we can see that it will be, LHS will be 1 into 3 plus 2 into 4 plus dash dash up to m plus 1 and m plus 3. Okay. So this is a sequence and series type of category where we are having 1.3, 2.4 and like that, and n plus 2. So it is 1 into 3, 2 into 4, n into n plus 2. So there is difference of 2 to 2 in between them. Okay. So now we have to think how my RHS will look like. Now my RHS over here is 1 by 6 n, n plus 1, 2 n plus 7. So for my RHS I have to substitute n is equal to m plus 1. So how my RHS will look like? Let me write it over here. My RHS will look like 1 by 6 m plus 1, m plus 2 and 2m plus 9. Okay, substitute n is equal to m plus 1, then you will get 2m plus 2 plus 7, which is 2m plus 9. So this should be our aim. Okay. So let me write one more term over here, which is the mth term, which is our m plus 2. After that there will be m plus 1 and m plus 3. So this is how my LHS will look like. Now till this m term I can substitute my concrete statement, which is 1 by 6 m plus 1 2m plus 7. Okay, m plus 1, 2m plus 7, and we are left with our m plus 1th term, which is m plus 1, m plus 3. Okay, which is m plus 1 and m plus 3. Now take m plus 1 common from this. Okay, take m plus 1 common from this. Then it will be m plus 1 m by 6 2m plus 7 plus m plus 3. Okay, if you take m plus 1 common from these two, you will get m by 6, 2m plus 7 and m plus 3, right? Now let me rub out this initial check step. This is not required. This is just for a basic check. So in this I will multiply m with 2m plus 1. So I will be left with m plus 1. It will be 2m square plus 7m by 6 plus m plus 3. Okay, so this is what I will be left with. Now you take m plus 1 out and you take 6 as LCM, then you will get 2m square plus 7m plus 6m plus 18 by 6. Okay, now it will be m plus 1 you club the middle m terms, then it will be 13m plus 18. 6m plus 7m is 13. Now 2, 18, it is 36. 13 can be splitted as 9 into 9 plus 4. 9 plus 4 and 9 into 4 is 36. So by splitting middle term, we will get it as m plus 1 2m square plus 9m plus 4m plus 18 whole by 6. Okay, so this is what we got now. Now we will take m common from this, then you will get 2m plus 3. You take 2 common plus from this, then you will get 2m plus 9. Here you will get 2m plus 9, here you will get 2m plus 9. So it will be m plus 1. You take 2m common, then you will get m plus 9. Here you take 2 common, you will get, here you take m common, then you will get 2m plus 9. Sorry, I will rewrite it. It will be, you take m common, 2m plus 9. Here you take 2 common, then you will get 2m plus 9 whole divided by 6. It will be m plus 1, m plus 2, 2m plus 9 whole divided by 6. Now we had arrived what we thought of. We thought of that it will RHS will be look like 1 by 6 m plus 1 m plus 2 2m plus 9. Okay, so this completes the category 3 of the problem, which is the series type of problem. Now we will move on to our category 4, which is the divisibility type. Let me rub this board out. Now let's come to our fourth category. In fourth category, we are having divisibility problem. In divisibility problem, we can see that it is n cube minus 7n plus 3. So this is divisible by 3. That means we can write this entire expression in the form of 3 lambda. Okay, we can write this entire expression in the form of 3 lambda. Now let's get started with our principle of mathematical induction. So my first step is of initial check P1. I will substitute n is equal to 1 in this. So once I substitute n is equal to 1 in this, I will get my LHS as 1 cube minus 7 plus 3. This is equal to 1 minus 7 plus 3, which is equal to minus 3, which is in the form of 3 into minus 1, where minus 1 is my lambda. So minus 1 is my lambda, hence this is divisible by 3. Okay, so my P1 check is done. My RHS is 3 lambda, where lambda is equal to minus 1. So this my P1 check is done and my P1 is true. Now let's come to my second step, which we assume that PM is true, and let's come up with a concrete statement. So concrete statement for this will be, let's substitute n with m. Then you will get m cube minus 7m plus 3. This is equal to 3 lambda. Okay, because this is divisible by 3, so this is equal to 3 lambda. Now, third step, which is induction step. So how my Pm plus 1 will look like? For Pm plus 1, let's take our LHS. In this LHS, it will be m plus 1 whole cube minus 7 m plus 1 plus 3. Okay, this is how my LHS will look like. Now, what I should anticipate what my RHS will be, right, in this step. So I should show that this will be equal to 3k. 3k means it is also divisible by 3 with left with an integer k. Okay, so I will show that this will be equal to 3k. Now let's expand this m plus 1 whole cube. It will be m cube plus 3m square plus 3m plus 1. This expansion we had done in earlier problem, how to expand with the Pascal triangle. So we will draw the Pascal triangle and we will use the same theory to expand this. Okay, now you will be having 7m minus 7 plus 3. Okay, 7m minus 7 plus 3. Now just club entire terms, then you will get m cube. So before clubbing, let's see what my concrete statement is. My concrete statement is m cube minus 7m plus 3. So let's take m cube minus 7m plus 3 out. So you will get m cube minus 7m plus 3. This one you get it out. Now you are left with now 3m square, 3m, 1 and minus 7. So let's write this in separate box, which is 3m square plus 3m plus 1 minus 7. Done? Okay. So from my concrete statement I got this is equal to 3 lambda. So I will substitute this with 3 lambda. Okay. Now in this 1 minus 7 will become minus 6. So it will be 3m square plus 3m minus 6. Okay. It will be 3m square plus 3m minus 6. Now I will rub this initial check statement and we will write it here. So my LHS will be 3 lambda plus, you take 3 common from there. So it will be, once you take 3 common, it will be m square plus m minus 2. So in this 3 lambda divisible by 3, m square plus m minus 2. This will be an integer. So 3 into integer is also divisible by 3. So once you take 3 outside common, it will be lambda plus m square plus m minus 2. I will take this entire term as k. Then it will become 3k. Okay. So my Pm plus 1 is also divisible by 3. So what is my conclusion is? My conclusion is P of n is also true. P of n is also true. Okay, so this completes the detailed explanation 1 class. In this detailed explanation 1 class, we had come up with first 4 categories of the problem, and we had solved each and every problem with the detail. If you are happy with the content in this video, please press like, share and subscribe. Stay connected. Thank you.